had a great time at KubeCon in London 2025. And during my time, I sat down with Alan Shreve, the CEO and founder of ngrok. We had a fascinating conversation about ngrok's journey from a simple webhook testing tool to a full-scale API gateway platform. Alan shared insights on their philosophy of making infrastructure simple, their approach to multi-cluster networking, and some exciting new load balancing capabilities. It was an absolutely fantastic discussion about developer experience and the future of cloud-native networking. Let's dive right in.
Could you please take a moment to introduce yourself and tell us how you're finding KubeCon?
Yeah, I'm Alan Shreve. I'm the CEO and founder of ngrok. I've had a great time at KubeCon. Lots of really interesting technologies that are being introduced, and had so many great conversations with so many people out on the floor.
So you're the founder and CEO of ngrok. Can you tell us about what made you start a company around initially a dev tool moving into a networking stack for applications?
Yeah, ngrok was really founded on the principle of making developers more productive, and finding like the original use case for ngrok was getting a public URL for a service running on your laptop, which was useful for webhook testing. That was something that was slow to do, and so that kind of initial foundational mission of ngrok was speeding up developer workflows and making infrastructure that was difficult to put together, something that was really easy. And we've carried that mission forward through the years, and kind of what we said to ourselves was, hey, listen, like we built essentially, like when we were doing this webhook testing and getting URLs for your local machine, something that is essentially an API gateway to your local machine. But doing that same API gateway work in production is much more difficult than the single command it is to run ngrok on your laptop. And we wanted to bring that same simplicity and ease of use and power to the production world. And that's really informed our journey, moving from where we started to where we are now.
Yeah, I think one of the things I love is a complete outsider, someone who's just been using ngrok as a developer and as an operator, is that the attention to detail and the developer experience is what sets it apart from other solutions in this space. Every time I feel that I put ngrok into my infrastructure, my life gets easier. And this is clearly something that is I'm assuming some sort of company value, where it's like, how do we take a problem and how do we make it easier for people to be successful without having to get into the weeds of the technicalities and all the other things there. And as I've seen ngrok go from, like you said, a webhook tool to being my ingress controller in my cluster, which was a massive step forward in developer experience too, because I didn't need to have an AWS load balancer anymore. That all disappeared and ngrok became the front of my application. And then we had all of the traffic policy stuff, which is relatively new, I believe, to the ngrok, which allows me to have authentication in front of my application and a couple of lines of YAML. And it's these little niceties that I think it's just a breath of fresh air in a cloud-native world where everything seems to be getting more complicated, and ngrok are going the opposite way. And I just think that's a fantastic story to tell, and it's interesting to see from the outside of this as well.
Thank you so much. Those are such kind words. It is something that we care deeply about in across the entire company, in the creation of the product, the product feedback cycle that we run, to build things that make it easier to run infrastructure. And it goes back to that original mission that we talked about, right? Which is about focusing on that developer experience, on creating power and flexibility at a great abstraction without giving up. There are any number of times that you create an abstraction, right, that you put in front of something and it removes power from you. And so striking that balance where you get power and flexibility, but you also get ease of use, is an interesting tightrope to walk, and one that we spend a lot of time thinking about, trying to get right. ngrok, in terms of its API gateway journey, has built many iterations over the years of ways to put that functionality in front, right? When I say that functionality, what I mean is that kind of traffic policy functionality of, hey, we can manipulate the traffic as it comes through, right? We can enforce authentication, we can do rate limiting, we can route traffic to different backends. The very first versions of ngrok long ago had a switch to like add basic auth, but that was like one thing that it could do. Our language these days is far more powerful. But we've gone through many iterations of what that API design looks like, and honestly, we got a lot of them wrong. And so it is a constant process of, trying to get that design right, designing it, and seeing how it works, using it ourselves, right, to test that. We dog food ngrok for all the things that we do. Ngrok is in front of our API, it's in front of our dashboard, it's in front of our website, and we use that to feed into our product process of saying, like, is this good enough? Is this something that we want to use? Just as much as, like, is it something that the whole developer world is going to want to use?
Yeah, I think this is something that should be more common, this whole dogfooding aspect. Like, if your developers aren't getting frustrated with your product and finding ways to make that a continuous improvement cycle with every sprint or whatever method you're using for working, are you really understanding the pain of your customers? Are you building the right product? And I wish that more companies adopted that philosophy. But, you mentioned API gateways. Obviously, ngrok is evolving now to a Kubernetes world, right? We're at KubeCon, there's 13,000 people here. Everyone is now, whether they like it or not, running Kubernetes. And with ngrok, we have the Kubernetes operator and we have the gateway I support. But at the same time, you have your own CRDs to do API gateway semantics and traffic policies in this. How do you find this migration to a Kubernetes world? And I'm assuming, people are here with Kubernetes. They're not running a monolithic application on Kubernetes. I hope they're not running a monolithic application on Kubernetes. They have microservices. API gateways have never been more important. And how have you found that new problem space, and how are you tackling that?
We at ngrok have been running Kubernetes since, 2017, 2018, a while now. So we have plenty of experience with it. Building a product for that ecosystem has been great. It's been a great experience. It is, one thing I would say is, like, I would not frame it exactly as ngrok is migrating to Kubernetes so much as we are expanding into that space. All the things that you could do before with ngrok are still possible. And the way that we, have built the Kubernetes product, right, is that it is the piece of ngrok that extends into the Kubernetes world that understands Kubernetes natively, right? It works with the ingress objects, it works with the gateway objects, and yes, we have our own CRs as well. But we're really finding a way to tie into that ecosystem and make ngrok, which is, a globally distributed API gateway, as a service, something that you can provision natively from Kubernetes, just as much as, like, the original version of ngrok was, hey, how do we take this globally distributed API gateway as a service and make it fit really nicely on a command line? This is another modality in which you consume, like, those gateway services is Kubernetes. And Kubernetes, the folks who have been, in the cloud native world have been thinking about, like, what is the shape of an API gateway that looks really good and feels really good for Kubernetes. The first iteration being the ingress objects and this latest iteration being the gateway API. And so, when we said, hey, we want to really do this right, we said, like, great, well, there are some ways in which our primitives, like, don't exactly map to that. So CRs are the right approach for that. And other ways in which we can, like, natively support exactly the standards that are created by the CNCF for supporting the workloads that make sense on a Kubernetes environment. So I don't know, it's been a good experience. We're really happy to be there. We use our own operator ourselves to expose our own services that are running inside of Kubernetes. It's great.
So I'm not sure how your conversations have been as you've been on the booth and you've been speaking to people here, right? But I'm assuming that people understand the problem space, they understand the solution. And let's assume a lot of people leave here and they start putting ngrok in their clusters. You now become a critical path in their critical path, right, for their customers to their product.
Yeah.
But now that you have this real estate within customers' clusters, do you plan to broaden that to make and simplify, maybe encroach on the service mesh part of it, the workload to workload aspect of it? Is that something that you're looking at down the line, or do you feel that your main value purpose to people is the API gateway aspect of what you're doing?
We really want to go where our customers take us, and so whether we, like, expand within cluster or not kind of depends on how what our customers say and what developers out in the world look for and need for. One of the things that, as we've gotten further into the Kubernetes space, one of the problems that we identified was essentially getting two Kubernetes clusters to speak to each other, even if they are in completely different networks, completely different clouds, with minimal configuration. And so that is one of the pieces that we have also built recently that we call Kubernetes bindings or Kubernetes endpoints, where you can essentially have one Kubernetes cluster create an endpoint in ngrok's cloud service that appears magically in other Kubernetes clusters where you install our operator. So that is one place that we've already expanded inside of the Kubernetes ecosystem with additional functionality that you could load in. Additional plans inside of the CNCF. There are new things coming out for the Gateway API at each KubeCon as more SIGs get approved. So expect us to be evaluating those for inclusion. Those are kind of what our plans look like inside of the cloud native world at the moment.
All right, I'm going to come back to the multi-cloud thing first, but I'm going to ask one more question with regard to the service mesh angle, because one of the really unique prospects of ngrok is that you have these multi-language SDKs. Now, I'm not sure how familiar you are with the service mesh world, but I assume you've got your eyes on things, right? There's a very divide right now. We've got projects like Linkerd, which is a CNCF graduated project, that is the sidecar model with no plans to ever change that. The sidecar model being we run an extra container inside of every pod. And that makes a lot of people angry because they're like, why do I have to over-provision all of these resources for that sidecar mentality? So now we have Istio, which is going down the ambient mesh route with zTunnel, but there's security concerns of having a super privileged proxy running all of my nodes, managing the TLS certificates for all of my workloads. And people aren't exactly ideal with that, but they love the cost optimizations. And I keep looking at this problem and I'm going, well, ngrok has an SDK for Rust and for JavaScript and for Go. I don't need a sidecar. I just need to wrap the entry point of my application. And it's one line of code by these SDKs. And I have access to Kubernetes endpoints. I can do workload to workload MTLS. So it's to me, I'm why are people not seeing the value proposition here as well? And I would love to see that become more aware to people. And I'm curious if this is something you see you dogfood a lot. Are you using the SDKs in this fashion? Is this something you've explored, you've tried, you've experimented with?
It's an interesting question, and the service mesh space is an interesting one. ngrok at the moment, for an inter-cluster kind of service mesh, the model that we run in today doesn't really make sense for service mesh in that when traffic flows through ngrok, it bounces through our cloud service, which for ingress makes sense, right? It's coming from the outside world. It needs to come into the cluster. For two services that are sitting in the same cluster, having them, bounce out to our cloud and back, doesn't make a whole lot of sense. However, what I would say is, I agree with you that the programming model makes more sense. And so one of the things that we're particularly excited about is just the belief that we should be when you're thinking about service mesh, when you're thinking about the kind of problems that folks are tackling in that space, we are still thinking at layer 4, which is an interesting place to be for all of us infrastructure engineers and platform engineers who are building out these services. But when you use the internet as a consumer, we only deal at layer 7. When we put things in our web browsers, when we configure where our things point to, our webhooks, we predominantly use layer 7, but inside of our clusters, we're still sitting at layer 4. And I think that creates a number of problems around that space, and I'm interested to see where that ecosystem goes. Does it go more towards layer 7, the way that we think about the broader internet? And I expect it will, because one of the things that we've seen over time is that the internet operates at massive scale, and so a lot of the things that we've had to do to make the internet work, thinking about things in this layer 7 way, they increasingly become more relevant to our own networks as our own networks have expanded, right? There was, 10, 20 years ago, we said hey, we have a few monolithic applications. Maybe you have one monolithic application that we run, we don't need a bunch of URLs. We don't need to think about all of these different things. But now in this world, we're like, oh, hey, we run hundreds of services, or in some cases, like some organizations are running thousands of services. You start approaching these scaling points where you operate more like the broader internet, and those kind of solutions, which require their own infrastructure, like we have to build that stuff to support them, start becoming more relevant.
Nice. Okay. Perfect. All right, let's go back to the multi-cluster strategy then. Yeah. So you're probably not aware, but I ran around the showcase yesterday for far too many hours interviewing people with just 3 really basic questions. How many clusters do you have? What version is it? And how many nodes do you have? And the general consensus seems to be people want to do multi-cluster, but they're not willing to pay the tax of going multi-cluster. But that want and that desire to not have a single point of failure with one Kubernetes control plane, to break things down, to do cell-based architectures, there's a lot of buzz, there's a lot of conversations about this. But unfortunately, it's not an easy thing to do. Now, for the people watching this that are maybe not familiar with what Kubernetes endpoints are, can you give us an idea of how those fit into this multi-cluster strategy and how it can enable them to be successful?
Yeah. Although I'm curious, like, when people said they were running, like, when you said the cost of multi-cluster, do you mean like the actual like cost to run multiple clusters in dollars or currency or
mental fatigue?
Mental fatigue, yeah. Yeah, I've talked to a number of folks. I was talking to people yesterday about that, about their challenges abound in doing multi-cluster, and they get worse when you go to multi-cloud, right? But yeah, problems with policy and standardization, and then one of the other pieces, right, is the networking piece, and that's the place where we built Kubernetes bindings that we have felt has solved a piece of the multi-cluster problem, although there are many other problems with multi-cluster beyond just the networking piece.
Yeah, so from the conversations I've had with people, when I talk about that mental fatigue, is like, one, okay, I'm responsible for multiple clusters, right? But they can get past that, right? You build the right, playbooks and runbooks, you build the SRE culture, people can get on with that. But then there's this big looming thing of workload identity across multiple clusters. There's a reason people are not adopting Spiffy and Spire and mass adoption, right? Because it's hard, it's very academic, and people don't understand that problem space. But when you have something like ngrok that sits in my cluster and it can handle some of those workload identity situations, things do become a little bit easier because you have some level of trust with this networking across cluster. And I think that's what I like with the Kubernetes bindings. It's a very simple API. Again, that seems to be the philosophy of ngrok, but make it simple just to say, I want to speak to this service over here. And ngrok then powers that communication. Do you go down the route of having workload identity? Do I have access to all the traffic policies? Can I do MTLS? Like, how far does ngrok push this and enable multi-cluster workloads?
That's a good question. When you say workload identity, tell me more about what you mean by that.
So having a policy that says I have application A and only application A is allowed to speak to this Redis database, so this MySQL or this Postgres, etc., right? And people are doing this with service mesh, with MTLS. When I bring ngrok into this, because I am going through the public API gateway, I have access to traffic policies. And I'm assuming there's a very natural fit there to handle some of these challenges as well.
Yeah, 100%. Like, that's, designing traffic policy, like doing, identity is one of the core pieces of an API gateway, right? Of enforcing like identity boundaries, identity permissions, like that auth and auth-z story is, one of the core pieces. And so the Kubernetes bindings that we built, right? The ability to say, hey, I'm going to create a service object in another Kubernetes cluster that when you speak to it, routes back to another Kubernetes cluster or another virtual machine or something that doesn't even run inside of Kubernetes, a Postgres database, whatever. It is essentially like creating a API gateway path between those two clusters, which when people do multi-cluster today, many of them do that. They have to, right? Especially if they're spanning multiple clouds, is they're standing up gateways on both of their clusters to be able to communicate between those two things. We really saw that pattern and said, how do we take the same philosophy that we think about with ngrok of making things incredibly simple and provide it in an interface that feels Kubernetes native and simple to use. We really started with, and you can see that in just the demo of the piece where you say great, I Helm install the ngrok operator in this cluster, and then I start the ngrok agent, or I run the ngrok operator in another cluster, and I create a single CRD, and the endpoint appears inside of the other cluster. We wanted to make sure that that simplicity was really one of the things that like struck you, that it made it very easy without thinking about all the networking pieces that were involved.
Okay, awesome. I mean, let's address the elephant in the room now. We've not mentioned AI yet. I mean, this is KubeCon AI edition. It feels like everyone's talking about AI. I mean, I don't suspect you have plans for any AI stuff, right?
There are lots of interesting things for ngrok to do in the AI space. It's a really interesting space, and we're really excited by it as well. There were talks already at KubeCon about AI's impact on networking and API gateways and pieces like that. One of the many interesting things that LLMs have brought into the API gateway space is that the workload pattern looks very different than what we're used to, right? It used to be that you send requests to application servers, and they all respond with relatively like small payloads, some HTML or some small like JSON blobs, and they all take approximately the same amount of time. With AI workloads, like requests to the same endpoints can sometimes take a tenth of a second or 100 seconds to like return your response. And those 100 seconds are not spent waiting, they're spent doing very intensive compute. So there are a lot of new interesting challenges in that space, and they are ones that we are thinking about and thinking about ways that we will offer solutions to those problems in that space.
Yeah. One of the things I've seen recently, people using the OPI specifications to define agentic workloads. So they're giving the AI enough information to be able to use OpenAPI as like a tool call. And I think that's quite an interesting space. But I'm not super knowledgeable there. I'm not going to go down that avenue. I'm just going to bow out while I can. But I'd love to know, just as a technologist now and not as like the CEO of ngrok, you're at a conference where there's, hundreds, maybe thousands of vendors. I'm not even sure at this point. But what technologies have you found exciting and interesting as you've been walking around the conference this week?
That's a good question. It truly is a cliche that what we were talking about before, that AI is on everyone's mind. But I'm personally like super excited about working with those tools and using them. One of the things that, as developers, we 30, 40 years ago, like started writing assembly language and have been continuously like finding higher layers of abstraction, whether that's, working in a compiled language or working in interpreted languages, continually like going up the stack. To me, like the unlock for LLMs and AI in general that allow us to really build at higher layers of abstraction, those are exciting new tools to have in our tool belt. I've been really excited using those things already.
Awesome.
Yeah.
Are there any questions that I've not asked you yet that you would like to cover before we wrap this up?
I think there's one other thing that is interesting, which is one of the other things that we've built recently is essentially like a new load balancing capability that is very relevant to multi-cluster. And so I think that might be an interesting thing to chat a little bit about.
All right. So can you give me the overview? What is this new load balancing thing that you've been working on?
Yeah. So essentially, like when you are working, when you use ngrok, right, you run ngrok, and whether it's from the CLI or from the operator, as we were talking about earlier, and you get a URL, right? Previously, if you tried to run two ngrok CLIs or operator ingress objects with the same URL, one of them would conflict and say, hey, something is already using that URL. The new feature that we've added, which we call endpoint pools, allows you to run two ngrok endpoints with the same URL. And when you do, we load balance between those two endpoints, no matter where those two endpoints came from, which means that you can essentially create the same ingress or gateway object in any number of Kubernetes clusters running anywhere across any number of clouds or on-prem resources or your laptop, whatever it is. And if they all have the same URL, which would happen if you just applied the exact same ingress object, we will load balance to all of them.
Okay, that's really cool. So how much control do I have over how, is it round robin? Can I do geolocation routing? Is there header-based routing? I'm assuming the traffic policies allow me to hook into this as well. But like, I can imagine if I'm running ngrok in the US and in Europe with something in Australia, is that I'm then getting the lowest latency possible.
That's right. So when we do this, when we do endpoint pooling load balancing, when traffic comes into a point of presence, we try to route it to your application servers that are closest to that point of presence as well. So you kind of get this automatic global load balancing for free. That's one piece of it. Like you mentioned, each of the endpoints that you start has traffic policy on it. And so you can essentially like choose to route the traffic how you would like. If you want to specifically pin traffic to a given region, that is a thing that you can do. The other thing that is very unique about the approach is that each endpoint actually can specify its own traffic policy, which means that each, with like typical like gateways or load balancers, you have one set of behaviors that must happen, and then it sends traffic to all of the backends. Whether like an example would be add a header, right? So it adds a header and then it forwards to each of the backends. In ngrok's world, traffic policy can be different. So one endpoint can add one header and another one cannot add a header, and another one could add a different header. Depending on which one you get load balanced to, it will take a different behavior. That may sound weird, but what it does is, like, for folks who run and operate these systems, all of them know that updating that configuration is one of the most terrifying like buttons that you can press, because it's a very easy way where you get it wrong and you break all of your traffic immediately. And so the model that we've created allows you to essentially like canary test the API gateway configuration, the load balancer configuration that you previously were not able to like test in a partial or safe way. So particularly excited about that, and very excited about, like you said, as people are struggling with multi-cluster, one of the things is, hey, like doing ingress and balancing within a cluster, very easy, but doing ingress and balancing across many clusters, across many clouds, not a solved problem. And we're very excited that we've made that piece so easy, as well as just, hey, we just apply the same ingress object in multiple clusters and it just works.
Yeah. I mean, for the people that are not aware, the reason I feel that this bit becomes easier when you use ngrok is that those traffic policies allow us to do things like on an error on this individual machine, forward it on to another internal endpoint or even another external endpoint, or even just fail over to another machine. And that convenience, again, of 1 to 2 lines of YAML and allowing me to do a canary deploy and test a new configuration in one region, but have it fizzle over to another region if it has to, that I get more sleep. And when I'm getting more sleep, I've got a smile on my face. So.
We like you getting more sleep.
All right. Well, thank you so much for your time today. It's been a pleasure.
David, it's been a pleasure. It's so good to see you again, and great to be here at KubeCon again.